And we're on the air. Hello, friends. Welcome to another episode of Codementor Office Hours. My name is Mark, and you mysteriously can't see me because my laptop camera is down today, but I am here. and thank you so much for joining. If this is your first time watching, basically what we do is we hang out online and sync up with some experts that we're really big fans of and try to dig in on a new technical topic that maybe some of our community has been challenged by, or we just feel like there isn't a lot of information out there about. And try to dig in. So before I introduce our guests, just a little housekeeping. If you're able to join the live room we're in, you can feel free to throw questions in via the group chat. I see we have some people watching from the Google Plus page. There should be a little Q&A app. It can be hard to find, but it's like neon colored. And if you click that, I'll get those questions that you send in, and we'll try to hit as many as we can at the end. But without further ado, today's guests, we actually have two guests today. First off, Matt Barrett. Matt is the director at Adaptive Consulting. He's been involved with building reliable, scalable systems in both television and financial services, and has seen the similarities and differences in their approaches to reliability and functionality. He was introduced to the concepts of the Reactive manifesto via Microsoft's RX when building a single dealer platform for an investment bank a number of years ago, and he hasn't looked back since. He blogs over at weareadaptive.com/blog. And Matt is joined today by Lee Campbell. Lee is the author of the 5-star rated ebook and website intro to rx.com. He's a full stack developer that works primarily in .NET with a focus on building reactive systems. He's a consultant at weareadaptive.com and is an international public speaker. So today, Matt and Lee are going to be discussing how to architect and then build event-driven user interfaces. So please welcome Matt and Lee.
Thanks very much, Mark. Great to be here. So I guess we should, if we're gonna throw things out like architecting and building event-driven user interfaces, we should probably talk about the sort of applications that are event-driven, because it's not necessarily the case that all applications are event-driven. And if you try and take some of these architectural principles and use them where they're not meant to be used, you can find yourself doing a little bit more harm than good. So you've got some.
I think it's interesting to think of the brave new world as moving to a notification-based system. So Twitter's the classic example, or chat messages. So we want to have that kind of stuff pushed to us. We don't want to go out and poll. The more canonical example that we use in our industry is a trading application where we want to have prices, whether they're from a stock market or from an exchange, pushed to the client so they can make real-time decisions as prices are pushed to them. They don't want to ask for prices every time they want to make a decision. They have those prices pushed to them. And we've even seen it pushed out. More recently, we've been doing some integration with GitHub and Travis CI. And you don't want to be doing polling and things like that, even in this document collaboration systems that we see, Google Docs. So you'll see that things become event-driven, push-based, even in things that maybe people perceive might be a REST polling kind of world. Event-driven's taking over in that space as well.
Yeah, as things go, everything becomes social, which I think is a trend we've seen over the last few years. There becomes a lot more people on the other end of the application than just you. So if you're really the only user of the application, like you're sitting there writing Microsoft Word, a Word document online, sorry, not online, just on your desktop. Well, it's not really an event-driven user interface in the way we describe it. Clearly, there are events when the user's pushing buttons, but there's an event loop within the application. The events we talk about are ones that are coming from a distributed system somewhere else and being delivered over a network. And those event-driven user interfaces are things like Google Docs, for example. So a lot of people can collaborate on a Google document online, and it takes document writing from a one-person endeavor and made it social in a sense. So that's the sort of thing we build. And we specialize in financial services and capital markets here in London. And it's about building real-time decision support systems, exactly like Lee said, and pushing information to users in a reliable fashion. And people often ask why we spend the length of time we do diving into architecture and functionality and good principles and making sure everything works, but when most of the time there's not that many events. Maybe there's 10 or 15, 20 events per second, price updates per second. But actually what you find is that the sort of applications that we we build and the area that we work in, maybe 4 or 5 times a year, there will be a lot of market volatility. And the 20 updates a second will go to 100 or 200 or 1,000 updates a second. Not necessarily all coming into the UI, but the rate will get a magnitude or two different. And you need to have load tested and written your application in such a way that it can work at that scale, because those are the points in time when the market is most volatile and that the decisions you make are the most important. And you can win trades and lose and make a lot of money in a very short amount of time if you don't have the proper infrastructure in place to give you a view as to what's happening. One of the things that people talk about a lot in distributed stream-based systems, event-driven systems, is back pressure. Back pressure is an interesting one. We can talk more about it. We will talk a bit more about it further in the hour, but the need to give feedback upstream to say, you're sending me too many messages, you need to slow down. In our world, slowing down isn't an option, because our world, the numbers that are being displayed are the prices that instruments are being traded in the market. So saying, could you just slow down and give them to me a bit more slowly isn't an efficient way of doing it. What we need to do is shed load and drop messages and try and re-architect our UIs and our backend so that the latest bit of information gets to the head of the queue and is displayed on screen as quickly as possible. And it's a different approach traditionally than what people are used to, where you just download a file over FTP and you can just wait for it to arrive. And then on the other side of it, there's messages that can't be lost, which are the ones that are in response to a user clicking a button and trying to trade. And you clearly don't want to lose that, but that's like Amazon losing a buy command from a user for some box. That's their business. That's the last thing they want to lose. So we can show, to kind of put a bit of color on this, we'll just switch quickly over to an application that we wrote. Might be familiar to some of the listeners and the viewers. This is Reactive Trader. This is an application that looks somewhat similar to the applications we build for our clients that we clearly can't, or we're not allowed to share. This is a very simplistic version. A more complicated version that we would build for our clients would have a lot more detail being displayed and a lot more numbers on screen. But you can see here that we're getting prices published in. In fact, if anyone is watching online, they can go to this URL, which they should be able to see at the top of the screen, and they can see the same information that we can see. And if we place a trade, I'm clicking on the video, sorry. When we place a trade, we'll get a notification back saying that a trade was successful. And all this stuff is, this application is connected to a backend that everyone can connect to and everyone can kind of interact with online by placing trades with each other. And so those are the sorts of applications that we build. There's lots of information being streamed primarily at the user and a few actions that the user takes that need to be managed very carefully. So if those are the sorts of applications that we build, I guess if it was so easy, we wouldn't be in the consultancy business doing it for our clients. It would be something that would be very common knowledge, but it's not. And there's two things that make it difficult. One is that all of these interactions and all these systems are highly asynchronous, and the other is that they're massively concurrent.
Yeah. So asynchrony introduces a concept of time that isn't normally present in standard imperative coding or procedural coding. So when Matt talked about doing an FTP request, we can kind of think of that as a slow running method call, if you like. So you've got the concept of potentially it could time out, take a wee bit too long. But when you've got something that's asynchronous or event-driven, as Matt was talking about, the market or the producer could push all this data onto you. So now you've flipped over who controls the load. So the server may be pushing too much load at you, but you may also get a case where the server just doesn't respond. Now that's a slightly different problem to deal with for the UI. Is it just that there is no data currently happening? There's no trades happening, so we don't see any price movement? Or have we actually lost connectivity with the server? So just another piece of complexity gets added to the puzzle here.
Yeah, exactly right. We need to have built into the protocol that we build these applications the ability for the user to tell if something has gone wrong. It's not acceptable if we say that we send a new price every 4 seconds, and if we don't send one, then we need to tell the user that something's gone wrong. So those are the sort of SLAs that we build into our application that like guarantees that when the user looks at a bit of information on screen, it is accurate to within a specific period of time. And if we haven't had an update in that period of time, then we tell the user that something's gone wrong. So Reactive Trader is an open source application. Actually, we'll pass the links around to Mark afterwards, so everyone can download and have a play and look at some of the ways we've put this stuff together. And it's about making sure that the information you display is timely and correct as well as you can do. And there's a lot of difficulty in building an application with events at every level, which is what we're trying to do. So we're building event-driven user interfaces. In the example we just showed, there's prices being delivered, which are events. But then we also have sort of synthetic events. So when we don't see a message within 4 seconds, we inject a message to change the UI state so that it appears as though something has gone wrong, so the UI can react to that synthetic event. And these are all events at every level. So one of the things we talk about when we talk about event-driven UIs and RX in particular, and Lee can talk quite a bit about RX in a bit and how well it fits into this world, is that everything is a stream. And everything is a stream because those things that we traditionally think of as not moving, i.e. the compiled code of your application is not a stream, but some platforms like Erlang, the compiled code of your application is a stream. And that while your application is running, you can very easily have an updated version of some specific part of the code base, some library injected in, and suddenly start executing. And then the old code, the deprecated version, when it's no longer doing any work, will be unloaded and removed from memory. So in that model, which is a real stretch to imagine building a system where every single thing is just kind of an event that has a different set of behavior, it's difficult to imagine building that much asynchrony and that much concurrency with the tools we have today. And in the old days, and what I call the old days, about 7-8 years ago, before we started using RX, it was really the case that different platforms had different asynchronous APIs, had different ways and concepts of talking about asynchrony and reasoning about the behavior of code written in an asynchronous fashion. And it was also the case that those APIs that did exist on different platforms were very difficult to work with, you would need to become a guru in one of these APIs before you could effectively do asynchronous programming. But it's not the case with RX. You can become an expert in RX in .NET and also use it highly effectively in RX and Java in JavaScript and Java, Scala, so on and so forth. I guess I know my road to Damascus conversion on RX. What about yours, Lee?
Yeah, it's a similar sort of thing. I was building XAML, so WPF Silverlight applications for a financial institution, and they needed something very similar to what you saw Matt present earlier. Prior to that, there was lots of how we would build it. You would write lots of callback handlers that would deal with the event loop. So in WPF, that's the dispatcher. And it was a lot of chaining together. And what we found that really fell out the bottom was you could get okay performance and you could deal with messages coming in and that, but it was generally a single fire and forget, or you get one callback and you could deal with that. What became very difficult was when you would have error conditions or exceptions happen up and down the stack. How to deal with that became very difficult to wire that all the way through, and having a concept of not just that I'm sending a request, but I'm either idle or I'm processing or I'm in an exceptional state. Now, once I'm in one of those exceptional states, how do I now get back out into the idle or processing state? It became very difficult, and what I found in my sort of 5 years leading up to meeting RX was that these little tools libraries were getting built inside each project that I worked on, and with varying degrees of success. What was nice when RX came along, it was a very nice fit for the UI, hence its early adoption in Windows Phone. Silverlight, a lot of trading applications around London adopted it very quickly. And from what I understand now, it's hugely popular in the Android world as well. It's just a nice fit. And RX is probably just one slice of it. We're talking about event-driven UIs, so that's a nice bit of glue that we can use there. It's a callback handling pipeline, effectively. So if you've ever sort of piped stuff in a DOS prompt or in a bash shell, it's similar to that. You're just piping events through, and you just think of many things flowing through that pipe. If we were talking about back-end servers or something like that, you might talk more about message passing as opposed to callbacks. So when we talk about RX, we talk about callbacks, which is just a subtle difference, but worth noting.
And I guess the nice thing about RX in the front end is that you can have parity of event streams very easily. So the network and a sequence of events becomes as composable and usable as a network, as a series of key presses.
Yes, exactly. And so I believe his name is Andre Stoltz has done an interesting talk where he says, well, if the network or the IO layer, if you will, can be considered an event stream coming into your application, why not the keyboard or the mouse or the touch gestures shaking or anything like that also become an event stream? And he drives that model all the way to its logical conclusion, where you've got the user and the network, if you will, both being streams that affect each other, and they create this sort of Mobius loop, if you will.
So it's about the right tools for the job, and we find RX to be a very good tool for building these sort of applications. Lee's written a book, and we do training on it. RX is a tool, right? And it's important to properly assess the problem that you have and try and make best use of it. One of the things that we saw and we continue to see when we try to introduce teams to RX or introduce or do training is that if they don't have a problem that matches the sort of properties that RX has, that is a one-way flow of information and many events streaming over time, they really struggle to see the value. And to them, it's just a lot of complexity without much benefit. So what's great about .rx being picked up by the JavaScript community is that it really solves a lot of the problems they had with callback hell, for one thing. It's a much nicer way of structuring your code. But JavaScript developers have got a sort of implicit understanding of asynchrony, because they're all, everything's on a single event loop, and the code doesn't block. So they're very used to passing callbacks out and then receiving that callback sometime in the future. They don't know when it will run, and that makes RX a very good fit for JavaScript. When we introduce it to .NET and Java teams, there's a bit more resistance because they haven't had as much of an indoctrination, I guess you could say, into an asynchronous world. So for them, the shift in the normal way they go about coding is quite high. So you have to do a bit more. You have to give them more help. You have to give them a better problem to solve. And so we were fortunate when we first picked up this technology that we had real-time streaming applications all around us. That was our first-class problem, and so the technology fit really well with it. But it's not just about the UI. I guess we should talk a bit about end-to-end reactivity and event-driven systems.
I think this makes it a bit of a stick for some people to a hurdle for people to get over. Is okay, I understand that I can make key presses an event stream, and I can deal with that with RX or a technology similar to RX. But then at the end of my flow, I then just make an HTTP request. And that's a request response thing. You can kind of see that like a remote procedure call. We're sort of toying with the idea in the work that we do that HTTP request REST, that kind of model is a wee bit legacy for what we're trying to do now. And I think we'll start seeing the end of that. And it may be a bit presumptuous to say that, but I don't think if you're trying to build a reactive UI or an event-driven UI in the sense that we're talking about message passing, that a RPC model like HTTP or REST is going to be very useful. So we look to different communication models for that, and then backing on to the communication models, you'll want also a backend that handles an event-driven manner as well, which now SQL Server, Oracle, they're not really event-driven systems. So now we have to start looking at something else, maybe a Redis or a CouchDB or an event sourcing solution. So all of a sudden our designs in the UI may be driven from UX, which is something that We want this to be a more usable application. We want notifications. We want to be driving the user's decision based on data that we're providing to them. They shouldn't have to go out and poll. This can have it start off as being a user experience thing, then being a client UI thing, and then all of a sudden your communications model has changed, and now your back-end server code and your data stores have changed as well. So Matt, do you want to talk a little about communication models?
Yeah, absolutely. So we, like Lee said, we are starting to doubt the future of the REST model in the real-time web.
Do you want to explain why that sort of doesn't matter?
Yeah, absolutely. So back in the day, for a bit of historical context, early 2000s, the investment banks of the world started building the first e-commerce platforms. So the first way that they could push prices electronically to their clients over the public internet. Now, clearly before then, there was a lot of e-commerce going on and people had electronic ticker feeds and so on and so forth. But that typically used to be on private networks, leased lines, point-to-point connections between data centers or banks or hedge funds. What happened in the early 2000s is the sort of real-time push of FX initially, foreign exchange prices to clients connected via the public internet from their offices to allow clients to trade on those prices without additional infrastructure being set up. And in that world, the thing that started working was pushing prices over HTTP, but not directly over HTTP, over some kind of cobbled together accumulation of hacks to the HTTP protocol to allow the server to push data whenever it was required. At that time, people had a mix of application style. On one hand, they had the traditional request response, which was go and get data, go and make a request, give me back a single response. And then on the other side, they had connects to an endpoint, a streaming endpoint, and tell me all the prices for a certain currency pair and keep me updated forever. And there's a big difference there. One was traditional HTTP endpoints, request response, and the other was typically done using a mostly different technology stack. Over time, as we matured and the industry matured and got better at figuring out what it was that we were doing, we realized that the real-time streaming slice is possibly only, for some applications, 30 to 40% of the use case. But the complexity of having two different ways of going to a server and bringing back data means it's better to just have the more general solution that fits for both. And so it's clearly, if you have to do real-time streaming, then you need to figure out a way to do real-time streaming for simple request response. And so that's where we've kind of ended up in the last 3 or 4 years. So now that more and more of our clients are building their applications in HTML5 and JavaScript, which is really only a recent thing. A lot of big investment banks are still building applications or have been building applications in WPF or Java or WinForms or any of those kind of legacy GUI technologies. When you build in HTML5 and JavaScript, the sort of natural thing you do is you pick up the REST tooling that sort of infuses the world, and you go about your day. But on the side, you have this real-time streaming capability that is provided via WebSockets on the web. So the WebSockets are a fantastic example of sort of an evolution of a bunch of different techniques. Published, the specification was first proposed by a company called Kazing, who unsurprisingly work in this space. They provide a messaging broker that lets you push information to clients and receive back a stream of data from those same clients. And they realized that what they were doing was solving a very simple, not a simple problem. That's not true. They realized that they were solving the same problem over and over again, and that we should have an industry standard around it. And that's what the WebSocket is. But what we find the problem with it, with thinking about request response and then just taking that approach to streaming, is that you lose a lot of the benefits. So what's an example? An example is an application that has to manage accounts, the set of users that you were allowed to message or the set of clients you're allowed to see. When you log in the morning, in the REST world, you would go to the accounts service and ask for that set of accounts. What are the accounts I can see at the point in time that I asked? And you would get back a JSON structured message that says, here are the 30 or 40 accounts that you're able to see. If that set changes over the day, there's no natural way for REST to be able to tell you, for the server to be able to tell the client that something has changed. because it's the server that knows whether or not you have more accounts that you can see. It's somewhere back inside the infrastructure of the company or the application or the platform that you're building that knows that a new client or account has just been added. In the REST world, you have to wait for the client to come back and ask. But in a streaming world, you can do something different. But you have to model the protocol slightly differently. So instead of making that first request and saying, just tell me everything that I need to know about the current world, and then just shout things at me a bit later on, what you actually end up doing is sort of modeling the interaction between client and server as a stream of changes. And this is the sort of event sourcing world that Lee was referring to. And it's also something very similar. That sort of reasoning is also found in the new in the way we now store data at scale. So we don't tend to, the people that are at the forefront of this sort of thinking tend to say you shouldn't update data in place. The update statement in an SQL database is the problem. Mutable state is the problem. What you should be doing is just inserting new records that instruct the person that needs to reconstruct the state to mutate their internal state machine. So in the case of a new account being added, that means that we would send initially a message that contains the 30 accounts that we're able to see with some sort of tag on them saying, please add this account to your internal set of state. And then later on that day, when 3 or 4 more people are added, they would just be another 3 or 4 messages that are sent that add those extra accounts. And from the client's perspective, there's no difference in logic between receiving that first set of messages and then receiving the updates further down the line. Once you have a persistent connection between client and server, exactly like you do with a WebSocket, you need to think about how you do client-server interaction slightly differently, and that's a real challenge.
Yes, and to that point, deletion of data as well. Exactly. It just becomes another event. So the absence or the removal of data, same problem space. So you would send what I think is called a tombstone event. So account 123 is no longer part of your privilege set, or they've been decommissioned as an account. So we remove that from your internal state as well.
Exactly. And so the UI can very quickly react to these sorts of things. And not just accounts. Another good example of that we struggle with on a daily basis is permissioning and entitlements. So a lot of our clients have very particular requirements about being able to lock people out of parts of the application should they need to, at a moment's notice almost. Should they receive a phone call saying this person is doing something suspicious, please lock them out. Which means the whole application needs to be responsive to a change in permissions on startup. A change in permissions while the application is running. I mean, everyone has built sort of configuration-driven applications that receive a set of entitlements when the user logs in. You're told you can do X, Y, and Z, so those are the bits of the UI that we show. But people aren't so comfortable building UIs that can be told a change in permission during the user using the application after it's already been launched, and then having the UI be completely reconfigured. That's a real challenge. And it's where our use of RX really shines, because we can compose very easily the streams that represent configuration changes and entitlements, which are slow-moving streams but are very important, with the streams of price ticking that are very important as well, but much more fast-moving, and it gives them a sort of parity. So we really espouse the benefits of a single asynchronous API used throughout your application, even if the behavior of the asynchrony is slightly different. So what do I mean by that? A single response like login gives back, a single request like login gives back a single response, but we would still model it with RX, and we would still think about it as a stream that could yield more than once. It is unlikely that you get 2 login responses to a login request. That's probably a bug, but programmatically, it's easier to think about the fact that you can get many responses than the fact that you're only going to get a single one. And this comes back to that old programming saying, I guess, is that you should handle 0, 1, or many inputs. Those are the error conditions. You shouldn't just handle 0 or 1 because you might get more, and you can't just handle none because someone might actually send you something. So those are that sort of thinking is what drives the way we build and architect these applications. It's the fact that everything is a stream, and that we have to work with very powerful primitives that let us work with all the different types of streams. So those ones that yield many times a second, and those ones that if they don't yield every 4 seconds, there's an error, and then those ones that might only yield 2 or 3 times a day, or even once a week in the case of permissions being changed. All of that needs to sit at the same level in the application stack and the application architecture. There's something else that is tricky regarding moving to the streaming-based architecture, this event-driven architecture, I should say, and that is when dealing with ORMs, object relational mapping systems. So they do something very, very strange, and this isn't really something that happens in JavaScript, in the JavaScript world, because people don't tend to talk natively to a database in that way. But in the thick client world, it's very much a problem. So an ORM takes a relational schema, a set of data that is related to each other via keys, pulls it out of a database and sends it to the UI or the client, and then you reconstruct a full object graph from it. So you get back a nicely hydrated set of objects that you can dot through with properties. So you can go from account to users to orders to so on and so forth. But in a streaming world, we don't really have a point in time where we can stream the full object graph to the client, and nor would we want to. We don't want to have to stream 37 objects to pick a number to the client if only one of them changes. So what we end up with is a different architecture where each entity or each table in this sort of example becomes this individual stream of changes. So we talked about accounts being added or removed from the set that the user is able to work with. Equally, a change in a username on an account or the addition of another element to the other side of a one-to-many relationship is modeled as a stream. So that means that you can have 4 or 5, 6, a dozen, as many as you want, streams of tables being pushed from client, from server to client, and the client is able to reconstitute all those different streams, all that different asynchrony, and very elegantly put it all together and expose to the programmer only one bit of asynchrony. So that's the nice thing about RX, is that you can take 4 or 5 different asynchronous events and wrap them all up into one level of asynchrony, and that's the composability of it, and it's really highly effective. Yes. But getting people to understand the difference in the way you structure your backend is difficult, and that's the stuff that Lee was talking about.
Yeah. So yeah, it becomes. I'd probably go so far as if we made the leap from saying table to maybe it would be the aggregate route if we talked about DDD, domain-driven design, or CQRS. And there are things that work really well with this, which is potentially a surprise for some people when we talk about REST, ORMs. Domain-driven design is probably something that people are also thinking about. Interestingly, domain-driven design flows very nicely into CQRS. CQRS works really well with event streams and therefore RX in the UI. So that's an interesting takeaway. And if you've not heard of these concepts, then they're really interesting things to read up on as well. And then if we go a little bit further back, which is probably getting a bit far away from event-driven UIs, but it's probably worth just quickly mentioning, is that we've got these concurrent streams of data flowing across the network. Where do they come from? They come from these tables or something like that. Well, we're probably not going to be modeling tables, we're going to be modeling events, and these events would probably live in something like a distributed log. The hot topics at the moment are something like Akka persistence, Kafka, or event store, Greg Young's event store, get event store.
Get event store, yeah.
So this kind of stuff, again, very interesting, but if we're building UIs, maybe we're getting a bit too far away from the main topic here.
Yeah, but it's all about taking the traditionally static view of the world that the application is inert unless the user is doing something, and shifting it around to saying that the application is actually doing a lot, even when the user is just sitting there looking at it and not interacting with it.
Yeah, I think it's fair to think now, maybe I want to say 10 years ago, when or around the .com boom, we were building e-commerce sites which reacted, I'm thinking like building websites, that reacted when the user did something. When I would click on the add button, would go to the server, do something, update a table, come back and refresh the page, and then you'd check out and you go to a page and do this and that. I think that's where REST HTTP really did well. That was interesting. They could be stateless, the state was served in a database somewhere. What we see now is location, proximity, GPS kind of things happening, heartbeat sensors on your phone, people making phone calls, you're getting text messages, you're getting it from different accounts. So Matt and I obviously have a work email account, we have personal email accounts, we have previous personal email accounts, we have multiple phone numbers. All of these things are points of ingestion. We want to react to all sorts of these events. So if I'm writing mobile phone applications, my application needs to just deal with these local events, let alone stuff that's going to be sent from the server. I think that's the model we now need to think about, is that you're going to get flooded with data and it's going to be sent to you when the producer wants to send it to you. So the days of polling for something are kind of dead. And it's interesting to think that this isn't just in the space of trading and high finance. It's great to see that Microsoft RX is the thing we've talked about a couple of times now. That came out of Microsoft, but that's not a bad thing. That's one of the very good things they've done. And it's interesting that now Bing and Cortana, which is their voice-activated search like Siri or Google Talk, that runs completely off the latest version of RX, which is yet to be released. Another hot tech company at the moment, Netflix, they ported RX from .NET to Java and have made that very popular in the Java space. So it's a technology that's gaining a lot of ground, and I believe that in Silicon Valley, some of the big players, Oracle and that, which might seem interesting, that Microsoft Technology, Oracle are in on this as well.
Yeah, exactly. It's a wonderful API to pick up and use and put everywhere through your application. There's things that are hard to do after the fact when you're building an application code base, and one is error handling, because if you haven't put error handling in, it takes you almost as time as it took you to write the code the first time to go back and put it in. And the other thing is asynchrony. If you were presuming that some service would be in memory in the process of your application and you were calling it synchronously, it's very difficult to go in and re-engineer your application, your class hierarchy, your modules, whatever sort of structure you have in the language of your choice. It's very difficult to go in and put asynchrony afterwards. So one of the things we do when we build event-driven applications is err on the side of caution, and possibly maybe be very aggressive about putting in asynchronous boundaries between different layers of our application. So the UI talks to a view model sort of component that is able to map from the model being sent by the server to what the UI needs, so that the colors and the shapes, as Lee would call it. We need to put asynchrony in between all those boundaries, even though it may not be there at all parts of the object model, at all parts of the model. It may be that to begin with, we receive a piece of the model, say a date associated with some event or some bit of data when we receive the event. But actually, it turns out that later on, we need to go and look that up on a remote server. And that means that we're looking it up asynchronously. If we didn't encode in the application the first time round the fact that those events are that data is available asynchronously, it's really difficult to get right. And that level of asynchrony comes down to even the availability of the back end at all. So when you first load up one of these, what we would consider to be a successfully written event-driven UI, if the back end isn't there, the application still does something. It tries to make a connection to a server and doesn't hear back. But in the meantime, there's some UI showing on the screen, a spinner, or some other bit of Chrome that makes the UI and the user feel like, something is happening. One of the big things about the focus for us on building event-driven UIs is we have so many times, we have a lot of opportunity to interact with the user and give them the feeling that the application they're using is highly responsive and effective, which means they trust it. So a simple example is in a web page when you click a button or take some sort of action on the UI, and the UI doesn't change. You don't know whether you've clicked the button or not. We would always sort of acknowledge the fact that there's an asynchronous system sitting behind that button click, and that when you clicked the button, a network request occurred and we went off and talked to a backend server and got back a result or results. Sometimes that's quick and sometimes that's slow. And this is another one of those challenges that developers working on systems that are all sitting on their local LAN. They've got very powerful machines. They're using a development system that is not very loaded, that everything is quick. The data sets, I should say, are maybe not as large as they are when the application is pushed to production. All these implicit little bits of asynchrony can actually be very quick. And if something takes less than 125 milliseconds, it's invisible to a human. They don't tend to notice. But 125 milliseconds is an eighth of a second. In computing terms, that's a very long time. So there's a lot of things that can happen within 125 milliseconds when you're developing an application that suddenly take half a second, even more when you're out in production. And we all know the frustration of getting stuck in a bit of a UI.
Yeah.
That
an unresponsive part of the UI. And so part of that becomes, and this is maybe a bit towards UX now, is building in graceful degradation of your system. So if you happen to download Reactive Trader from GitHub, run it up and run both the fake server. This is a UI demonstration application, so the server's all fakery. But from that server, you can just turn off, stop listening on the port, stop producing prices. However, in the browser, you'll see that we will say we've lost connection, we're trying to reconnect. We'll give the user some feedback that yes, we have lost connection, but we're working on it now. And in a real trading application, excuse the fire engines outside, in a real trading application, we would probably say something like, look, you've lost connectivity, however, we still want your business. So your trader is Bob. Maybe you should give trader Bob a call on 555-1234, and we can keep working through this trade with him. And so you make them feel like, what you're trying to do is valuable. We can still get you to the end goal of what you're trying to do.
Exactly right. It's event-driven UIs don't have to just be about programmatic events.
No.
Thinking and modeling the problem domain as a series of asynchronous events is hugely important and really powerful. So we are big proponents of RX, but it's about the tools and the way of thinking that make it so interesting and so beneficial. There's so many applications out there that could be better if they were written in this way. That would be more interesting for the user, more engaging. There'd be a better experience, be more successful products if they were written in this way. And starting with the idea that your service may not even be there and your application has to keep running is a really good place to start. If you have a web app that you want a quick test that we do when we look at applications is start up the application and pull the network cable. So if we have a trading application that is designed to let you buy and sell capital market foreign exchange in real time, for example, when we're assessing these applications, we'll fire it up and just pull the network cable out and see what it does. And it's amazing that so many of them simply crash, which is really the last thing you want to do when you have an application that you're buying and selling millions and millions of dollars in is crash when someone trips over a network cable or an errant message comes through. It's about making the UI as resilient to all the different sorts of events that can occur as we should spend on trying to make the server-side infrastructure as resilient as it can be. And when we're sometimes seen as overplaying the importance of UX and design in this space, but we really think that when the transactions are worth as much as they are to the client, to the person who wants the software, it really is important to make sure you get all these design features and interactions right.
Yeah. And I think people are getting less and less friendly towards hostile environments like that. You sort of get one shot to get it right, and you either have to very quickly come back and say sorry and make it up and work twice as hard, or you just get it right the first time, because there's always another option. If you're Netflix, there's always Love Film or something else. If you're HSBC, there's always JP Morgan down the road. So, we want to, Mark, do we want to throw it out to questions, or would you like us to carry on for a bit?
Yeah, we can start putting the feelers out for their questions. If anyone has any questions, feel free to send some through the Q&A app. I'm watching there. I have a bunch that were emailed in. I can use to kick stuff off. But if you guys want to keep going a little bit longer, I can let you know when some questions come in, and then if we get to the last 10 or so minutes, we can cut right to the emailed questions.
All right, great, cool. Sounds good.
Okay, thanks.
So I thought that maybe we could go with a quick list of takeaways, so people have got something that they can take away. So when we're talking about event-driven UIs, maybe some top hits, things you can take away is errors. We talked about errors. So when we're doing asynchronous work, if you're a JavaScript developer, I think a lot of the libraries are already written to deal with that. You'll get a callback and you'll either get the value or the error. So that's great. If you're a JavaScript developer, you're already dealing with this kind of stuff. You put a layer of RX on there, and now you potentially can compose callbacks a little bit better than doing this sort of cow head shaped callback hell that can happen in JavaScript. So deal with your errors. If you're in Android or Cocoa, maybe in .NET or WinForms, if you can use a product like RX or maybe the TPL in .NET, again, make sure you handle your errors. If we're doing something that's concurrent on these non-JavaScript platforms, you've got multi-threading in there. If you have an exception thrown, maybe on the network thread, which isn't the dispatcher or the event loop for the UI, who knows how that's going to get handled. You're probably going to find that the application just crashes. Sometimes on some platforms, without warning, no error message or anything, you'll just see it, your application will just disappear. You won't have a chance to log that. So it sounds like quite an easy one, but make sure your error handling's in everywhere. So for us here at Adaptive, our simple thing is when you're using RX, that you always provide an on-error handler. So that's an easy takeaway there. Now we talked briefly, so that's hit one. Hit two.
Even if that on-error handler only logs,
yeah,
right?
That's fine.
But I know it's really annoying when people say handle your errors, but it's not always obvious what the right handling is to do. Just if all you can do is log it, then that's what you should do, because it will save you in the future.
Yeah, and maybe log it and shut the application down.
Exactly.
You've got options, but do something. Don't let the framework of choice, WinForms or Excel or Android, just do it for you. And then we talked briefly about concurrency models for JavaScript people. Not as interesting because you're a single-threaded environment. But if you're on Android, Cocoa, WinForms, WPF, then what I would strongly suggest is that you have a solid concurrency model, a mental model of your concurrency. And I find the most effective one is where you have one foreground thread, which is for the event loop, the thing that actually renders the content, and you have one background thread. And they're the only two places you do anything. So when someone clicks a button, you're on the event loop, the foreground thread, and you'll write your RX or your other asynchronous code in a fashion that as fast as you can, you take the information you need from the UI thread and then get onto another thread and then continue your work. So there you might do some logic checking, some error conditioning. You might have to map or translate to some sort of DTO and then make a network request, all doing this on some sort of background thread. Then you'd get the response potentially on the network thread, move that as again off the network thread because that's a precious resource, back into this background thread and process that data. Any exceptions can be handled there. And then finally, once you've wrapped up your final decision of what you're going to do, the last thing you do is jump back onto the UI thread and make the update to the UI for the user. So the reason we want to do that is that will keep your UI as responsive as possible. The minimum amount of work you do on the UI means that when people are resizing windows, they're clicking on things, you're getting hover overs, it'll remain responsive. If you start doing mapping, translating network calls on there, you're going to get a very unresponsive application.
Yeah, I guess the point is to recognize that in UI development, on iOS or on Android or even in the web with network calls, there is asynchrony and concurrency handling, and you need to understand where it is. A lot of people take a sort of blasé approach to threading and when they build UIs, and they kind of leave it to the server-side people to worry about the challenges of cross-thread communication and things like that. But actually, it is very much a UI problem, and UIs are inherently multi-threaded. I guarantee you that the GUI framework that you use of choice, whatever platform you're on, has got more than one thread responsible for rendering your information as it comes across from the network, and that's it's critical to get a handle on that.
And then in contrast to that, so I've recommended that you use a foreground and a background thread. I would also recommend that you don't use more than two threads. Once you start getting into a model, unless you're a very sophisticated concurrent developer, then it can be very confusing, especially for a team larger than 2 or 3. So if you can foreground, updating the colors and shapes, as I do sort of jokingly call it, and then the background thread for doing everything else. And then if we take that one step further, there's a network thread for just dealing with the IO there. But that's normally hidden from you in the communication product of your choice. So I would recommend against getting off the UI thread, doing something on a new thread and then moving to another thread to do something else and then do another thread to do something else. That becomes very confusing. And what I have found working with companies helping them in a concurrent space is that often removing this concurrency, all these extra layers of threading and concurrency, gave them a great performance increase, reduced the amount of code, and they had a much better application for it. The next thing, hit number 3, I would say, for us, as we've made it quite clear, our preferred tool is RX. When you pick a tool, for example, RX, prefer to use it the whole way down the stack, up and down the stack. So try not to use a little bit of async here and then move into some sort of synchronous blocking model and then back into asynchronous when you hit the network. Go asynchronous the whole way down and figure out with your tools how you can do some sort of continuation pattern. You don't want to be blocking anywhere. So if you can find out how to do that with RX, it's very easy. And you should be able to Google that, Stack Overflow, or just tweet us. That's very easy. And with other models, you can do it to maybe a little bit less elegant. So then the next thing I'd say, if you are using asynchrony all the way down, I would say try and pick one model of asynchrony and stick to it. So use .NET as another example. There's RX is one model of dealing with asynchrony, and then there's also other options like the TPL or parallel task library.
So that's in the JavaScript world, that's RX or versus promises and futures.
So a promise or a future is a nice tool to use. We like those as well. However, it becomes very difficult to switch between a single value future and a multi-value RX stream. An RX stream can produce a single value stream, which could feel like a future, but you do find that you get very subtle bugs in there. For example, you might find that your future promises library is eagerly evaluating the function, whereas RX will lazily evaluate functions. You can find that you can get interesting deadlocks or network calls that are happening when you didn't think they would happen because things are eagerly and some things are lazily evaluated. So I would recommend, if you do pick an asynchrony model, a concurrency model, go with that up and down the stack. Ideally, as we're saying, we would prefer a streaming model, and that's why RX is popular in our office. And I think I've already mentioned getting off the dispatcher fast. So the dispatcher, that's a WPF term, getting off the UI thread as fast as we can on the concurrent platforms. So JavaScript's okay, but if you're on WinForms,
iOS or
Android, you want to get off that render thread as fast as possible. And finally, a phrase that Matt's coined, sort of fifth hit, is everything is a stream. So try to think of everything as a stream. And when we say a stream, we mean a sequence of callbacks effectively. So you can think of a button click as an event that happens, and it happens many times. If you start to think of that event happening many times as a sequence of callbacks, you can start moving into the RX world, and then instead of thinking of just a callback, you think of a stream of callbacks. Then you can think of other things like scrolling, touching, swiping as other streams, and then you can start composing streams together, almost like you would compose arrays together to produce tables or object relational graphs. It's that kind of power, going from an array to a table or an array to a graph. You can go from simple callbacks to these complex composed streams. So they're my hit takeaways. I think is useful for someone to get started with this kind of stuff.
Absolutely.
Awesome. Thank you guys so much. This has been great. I want to jump to some questions before we run out of time. I'm also replaying in my head the terrifying situation you described of someone tripping over the wire, and like that. Like when you said that, it was just like pulsing in my head. I'm like, oh my god, I hope I never do that. So to start off, I was curious what you guys, how would you guys categorize the most common mistakes that developers just starting to work on, event-driven user interfaces make, and what should they think about doing differently if they're getting started in this work?
I think that the most common mistake is thinking and this is downplaying the importance of event-driven UIs, is to say that they actually thinking they have an event-driven problem when they don't. It can really feel like square peg, round hole if you're battling uphill with systems that aren't reactive. Event-driven systems are reactive. The reactive manifesto is a great bit of writing that captures that ethos. But if you are in a world where you have to poll a database for changes, you are not reactive. So building things in an event-driven manner will be unnatural, and it will be difficult to do. If you want to play around just on your own time, or in a project you've got to learn this sort of stuff, just wire up to the Twitter feed. The Twitter feed is a very good example of a lot of data being pushed at you, and try and build something interesting with that. There's not much polling going on when you're asking Twitter for data. They have a nice streaming API, and get familiar with it, and that's a great place to start. And once you've picked up and learnt some of the benefits and challenges of building that, you can confidently come back and take sort of re-architect your application that wasn't event-driven and make it so.
Gotcha. So, actually, since you mentioned, making sure you're actually working in reactive there, we've had a bunch of office hours about reactive, and one thing I always like to ask our guests is, can you guys talk about your process of first learning reactive, and sort of how you took your first steps with that?
Yeah, absolutely.
Yeah, we cut ourselves quite a lot. That is an interesting story, and it's probably a better one for the pub, but or the bar, should I say? So we were very lucky. Matt and I both picked up RX and this kind of model of work on a project that was very well funded, and so we were lucky to learn in where you normally work with a team of diverse capabilities. You've got some juniors, some middle guys, and some seniors, and maybe some architect type people. This was a very top heavy group of people. So while we did make a lot of mistakes, we were very lucky to learn off about 20 guys that you'd be very happy to code with any day of the week. So we made a lot of mistakes. I think we're all fair to say that, but we tried to document them, and the document was very unclear where we should put that. That document started off being a blog for a consultancy, and then maybe it should belong to the client, and then we thought, why don't we just make it a public blog? And that blog very quickly turned into introdirect.com, which was really a collection of all the mistakes we had made. How can we disseminate that to the next guy going to join the team? So effectively, we wrote a lot of silly things, and so this hit list that I've just given you, we didn't handle errors. So every now and then the app would just stop working. Oh, what happened there? Okay, not sure. We thought, well, if you want to make something faster, you parallelize it. How do you parallelize something? You make it more concurrent. So we just threw more and more threads at this application. That was something we did early on, or when we weren't sure where to put threading, we just erred on the side of just put some more in there. What happened there was we would drain out our thread pool, we would get blockages, we'd get live locks, and in some rare instances, I think 3 or 4 times we got deadlocks, which were just impossible for us to figure out what had happened. And we stopped, went back, we had a lot of smart guys, and we said, we're a bit smarter than this, let's just draw it on the wall. And as soon as we drew it on the wall, which is, so anyone out there want to Google RX marble diagrams, something like that, this is a way you can visualize your problem space. All the complexity starts to go away. When the visual becomes overly complex, your design's overly complex. When you start drawing what you really need it to do, then you just go and codify the picture on the wall. So I think there's some things we learned there, but we were very lucky to be working with such a group of people. It's a very rare scenario.
So the journey for me to sort of learn reactive was moving and working with Lee back in 2009, 2010, and finally seeing the problems that could be solved in this way. And that was really interesting and really exciting. And then at the same time, over the last 3 or 4 years, we've had a big push to the cloud, and then running into seeing a world where it wasn't so possible to be reactive. That if all we have is REST APIs and request response and polling, it's very difficult to build reactive UIs or reactive platforms, as talked about in the Reactive Manifesto. And that's the challenge. And it's interesting it's really instructive. It's a really good way of learning to do something one way and then try and do it in a different tool, a different framework. And you really quickly see the problems with this alternative approach or the benefits. We like the consultants that work for us. We really like that if they can be polyglot programmers, if they can work in multiple languages, because that experience of solving the same problem different ways, or approximately the same problem in different ways, I should say, is a great way of learning. You learn about deficiencies in your own understanding of the problem, and you also learn about advantages of doing things in different ways. And so that journey from doing having a really great problem and having the tools to solve it, to having the same problem and not having the tools, taught me a lot about what was good about the tools in the first place, which is really beneficial. And I know that we were very lucky to have a great problem space. And that's one thing I would say to developers looking to get into this stuff and learn how to do it, is find the problem that makes it work, that they can understand, and attack that. And try to make the most reactive event-driven system you can, have it collapse in a heap of complexity, and then step back and learn where the edge is that makes you feel the benefits but not feel too much of the pain.
Gotcha, makes sense. Well, guys, we're about out of time, but just one last thing. I mean, what are your sort of favorite resources that you recommend people check out to continue learning about the topics, whether it's user interface or reactive or any of the topics we've covered?
That's a good question, actually. You probably better.
I mean, I know there's a book by one of you, but
yeah, sure. So that's Intro to RX, but that's really just a deep dive on the API. So if you happen to choose that, then that can be useful for you, especially if you're a .NET user. You would pick it up if you did JavaScript. You squint and the things would still make sense. However, if you went to reactivex.io, there's a really good set of documentation that's starting to flourish out of there. It's community driven, so that's good. But as far as building reactive UIs or event-driven UIs, responsive UIs, I think they're the kind of terms that you want to Google. But you're going to get a lot of stuff from,
React.js.
React.js. You're going to get
responsive web design.
Responsive web design, which is going to be more UX kind of people talking about designs in the visual sense. So that becomes very difficult. If you say React UI, then that's a library, which is different again. It's a very overloaded space at the moment. And we did find it quite difficult to find good content on this kind of stuff.
The Twitter users we follow is probably a good place to start. Ben Christensen, who's the RX Java, leading the RX Java charge at Netflix, and Jafar Hussain, a JavaScript developer there, are great guys to follow to see what Netflix are doing at scale. I don't think they don't yet have quite the streaming problem that I think some applications do. So there are other places to see some other interesting stuff going on as well. The back-end reactive work is, look at what LinkedIn are releasing. Strangely enough, LinkedIn, really cool company, great product. And their challenges of real-time analytics are very interesting. And analytics is one place to look for great insight into what the real-time way of doing things can teach you, because there's very clever people with a very real problem there, which means they're motivated to find answers.
Gotcha. Well, thank you guys so much for your time, and obviously everyone should check out We Are Adaptive to learn more. I'm also going to be sending everyone who RSVP'd an email with a link to the recording and a link to the work of both these guys, so we can continue sort of following the story. But thanks so much for joining Codementor Office Hours for today. Check out, we have a bunch of great AMA sessions coming up next in the coming weeks, and without anything else, I'll say good afternoon, good morning, good evening, wherever you are in the world, and thanks for joining.
Thanks for having us, Mark.
Good talking to everyone.